because from what it sounds like, you really have a closed loop system here.
We do.
It's very holistic. Personally, I think it's the perfect thing to lead us forward as a society, where we're all focused on being healthier, organic, and becoming clean, and having a self-perpetuating society that will transitioning from a compartmentalized society to a holistic, self-perpetuating society.
This is true because we're talking about a complete cycle here. So anytime you do a complete cycle, you're producing good. One of our problems has been that we produce things and they're thrown away. Mm-hmm. This is one of our problems. So what we have to do is close that loop. And this is what we're doing. So basically, in this kind of technology, we're creating jobs. Mm-hmm. It's about a 2 million man-hour job to produce this complex because the plants are modular, depending on the municipal need. We can also do specialized plants for specific industries like mining. We can clean up mining waste. And it's a large return to capture waste for a mining owners, because all of that soil contains valuable items of precious metals. And so if you take this and you capture it, then you haven't wasted anything, you see? You can take it and run it through the plant and sell it back on the market.
So don't quote me on this, but it really sounds like you're the pioneer for closed loop systems.
The plasma plant actually has been around since the 80s.
Okay.
Started more or less in Japan. I'm not probably totally accurate on that, but that's the first plants that I know of.
Okay.
Because they had no landfill space.
Okay.
So it was a forced choice.
So this technology has actually been around.
Oh, it has. But we keep improving it. And one of the problems was with municipal power plants, mm-hmm. because of the waste and so forth, we weren't running really what was considered in the black. So we've now enhanced the system over many, many years, even as late as 2014. They were making breakthroughs in how to make the power plant more efficient, mm-hmm. primarily the power plant, because the products are the products, right?
Right.
Absolutely. But they have made technological enhancements. They're very complex enhancements. But they have done this so that the bottom line is we've increased the efficiency of power production, which has made us potentially operating in the black. And there are plants going up in Teesdale, England now for the first time in what's called MSW, which is Municipal Solid Waste Production for power. This is in England. First time, primarily due to the enhancements. So before, you have mainly government interest because you didn't have to worry about profits. Mm-hmm. And now we're segueing into the private industry where profits are, very realistic. Now, don't get me wrong, on the mining in private industry, you would make money from your recovered products. But we're talking about private industry in terms of utilities and things like that, which are now becoming profitable from this type of technology. Okay. Also in the experimental stage, as probably everybody out there knows, biofuels. Biofuels. So we can produce, theoretically, we can produce fuels like avgas and diesel from this process because you're using organics. This is still in the experimental stage, and I could not point to a single area where we have a plant operating like this, mm-hmm. but in experimental, they can do this. So it always starts there, right?
Right.
In experimental stage, then you progress into the production stage, if your concept works. Well, we already know biofuels is doing this all, now. So there wouldn't be any reason why we'd think we couldn't do it.
So not only is this, this power plant is a massive solution in itself, but it's like a tree that bears fruit.
Yes.
In a sense. And because I hear it like enriches the soil. Okay, it cleans the water. it, cuts out the pollution, and I just see like all these different fruits coming off of the limbs of
Yes,
the tree.
it is very much like that. The tree of life. It is the tree of life. We need to get back to the basics here.
Okay.
We need to get back of preserving our planet, our water, our air, and our soil, because nothing can live if we don't protect it. And this is not being dire, but it's just being realistic.
Okay.
If our oceans are polluted to a point where the species that live in the oceans can't survive, how do you expect us to survive? How do you expect our animals to survive? If you pollute to a certain point, everything starts to die, and then you get a problem that you can't reverse. And we're the only planet we know of we can live on.
Good point.
So we have to take this seriously, and we have to progress to the point where all of us are engaged in survival for our future generations. Even my grandchildren will be affected severely if we don't make changes now.
Okay.
Anybody's grandchildren. It's just the way our planet is going. The temperature's increasing. We know the storms are getting worse. They're all tied together. The whole of nature has to be considered a cycle. So what we want to do is recycle those things that we don't really need or are throwing away and use them.
So, what I hear out of what you're saying is like there's just been this power play that's been happening over time, and it's a compounded effect, and now it has led us to where we are from an environmental standpoint, but it's not too late. And
No, well, we're getting to a point where we're also almost at a point of no return. But it's like anything else, Malcolm. If you start an industry and you're making money at it and you're producing something that's of value, then it continues by inertia. It's not that anybody started out thinking, oh, well, I'm polluting this and I'm doing this and this is bad for our environment. It's just money. I mean, you come up with an idea, oh, we can produce power from this. Okay, and it just goes on by inertia. I don't think any of the people that are involved in these industries are bad people by definition. I don't. I just think it goes on because that's how it's been. Change is difficult. It requires us to stop and think. It requires us to think out of the box. It requires us to make an effort. All of these things are time consuming.
And uncomfortable.
It can be, because you have to critically think. And when you critically think, you sit down and say, well, who am I? I'm one person. It's like the drop in the bucket, right? If you have one drop in the bucket, not too much. But if you have 1,000 or 1,000,000 or 1,000,000,000 drops in the bucket, it makes a big difference. And if every one of us puts our drop in the bucket, we can contribute to the survival of our planet.
So is that why we're here today, to speak to the general public about
Yes.
what's going on?
Yes, that's why we're here. Because one person can't do it. As I said, it's not about me. It's got nothing to do with me. I'm just giving you a message of what is out there for us to deal with and how we can make change. And this is what we have to do. We have to stop and think what we're doing and make change before it's too late. None of us wants to destroy our planet. No one does. I'm sure of that.
So, yeah, I definitely want the planet to be around for some time, especially, if I plan to have children, and I want it to be healthy. I want it to be prosperous.
Well, there's a huge trend going on. A lot of people feel this way, but their voice isn't heard. We have to hear you. You have to step forward and help us. Get involved. What can I do?
So, where do we go from here?
Well, one of the biggest benefits, and I started alluding to this before, was money. The power plant has the least megawatt cost of any power plant in the industry. It's $2 to $3 million a megawatt.
Wow.
As opposed to, say, in the nuclear industry, and I'm not picking on it, I'm just saying it.
Okay.
It's like $11 to $1 million a megawatt.
Wow.
$8 to $11 million a megawatt.
That is a significant shift.
So if you're talking about 2 to 3 as compared to 8 to 11, And then what do you do with the nuclear waste?
I don't-
Nuclear power is clean power. There's no question. But what do you do with the waste?
I
You
don't
put it in
know.
a plasma plant at 10,000 degrees Fahrenheit, reduce it by a volume of 200%, and then you store it that way. Because 200% reduction is better than not, right?
Yeah.
Yeah.
So,
So the power plant, again, the plasma plant, comes to our rescue. It's kind of a panacea.
yeah, I'm discovering that. This is a really good thing, this power plant you have here.
Well, it isn't me that has it. I mean, there are brilliant minds that have developed it and perfected it, and it's available for use. It's all I'm doing is giving the message. I had no part in the development of the industry. I couldn't do it if I tried. I could not invent this. But there are brilliant people out there that have, and they've developed the enhancements. We have to give credit to these scientific people because they have created the possibility for this change.
Wow. Wow. Physicians, I mean, not physicians, people in physics, I believe you have a
Yeah.
background in physics as well.
Well, yes, I've studied physics for decades. I find that it's one of the most fascinating subjects there is in the universe, about the universe. And this plant operates on those precepts,
Okay.
which helps me to understand how it works, what it does.
Okay. Okay.
So what I like to do is show a very short PowerPoint to give you the guts of the system, how
Okay.
it actually works, so you can see it. And so that would be the next segment.
Okay. Well, we're going to get into that right now.
Okay.
And we're going to actually give, the general public a visual, some of the things
Yeah.
that you're talking about, make sure everybody's up to par. Because this is something really that's, in my opinion, too good for people not to know about it.
Yeah, I feel that way too. I think that if you have a solution, the public needs to know about it.
Okay, awesome. So
So-
we're going to get into that right now,
Yeah.
and then we'll get right back to you.
Okay, thank you.
All right, we'll do. Thank you.
As Malcolm and I discussed, we were going to show you the PowerPoint and give you the matrix of the system, how it works, and what it looks like. The first slide shows you here turning a liability into an asset. What we're doing here basically is taking the waste that no one wants and reconverting it back to usable products and electricity, which of course is a product. And you'll see from the chart that we have all types of waste, organic and inorganic. And this is what is our problem right now as to what to do with all this waste that our consumer-based society constantly produces. The plasma gasification system is shown there. This is a diagram of it, and what it is, it's a thermal operation operating at very high temperatures of 5,000 to 8,000 degrees Fahrenheit, and if you're working with high-level radioactive waste, up to 10,000 degrees Fahrenheit. This is an oxygen-starved environment, so you do not have combustion, which of course produces smoke. And so we're decomposing this waste into very usable products by molecular dissociation. And we get, as I mentioned before, usable products in the syngas, which is what goes into the power, hydrocarbon gases, and inert slag at the bottom for reuse in the cement and the road building industry. And also, we're exceeding environmental requirements. This is a very important chart. It shows the process from incineration to plasma, with the gasification being an intervening stage. First of all, if you look at the plasma on the left, the most important thing is the complete destruction of the waste or vaporization. Everything vaporizes at